Hello, everybody. My name is Mirko Novakovic. I am co-founder and CEO of Zero, and welcome to Code Red. Code, because we are talking about code, and red stands for requests, errors, and duration, the core metrics of observability. On this podcast, you will hear from leaders around our industry about what they are building, what's next in observability, and what you can do today to avoid your next outage. Today, my guest is Heinrich Hartmann. Heinrich is the senior principal SRE at Zalando, where he works on reliability practices and telemetry strategy on a large scale. Before Zalando, he was chief data scientist at Circonus and is well known in the SRE community for his work on statistics, latency monitoring, and reliability engineering. Heinrich, welcome to Code Red.
Hey, Mirko, good to be here.
Yeah, and every podcast starts with the first question, and that's what was your biggest Code Red moment in your career?
I brought you a Code Red moment. That was quite fun. This one was around Cyber Week a few years back. Cyber Week is financially our most important time of the year, so it was quite tense. And around that time, one of our infrastructure teams rolled out a change, a very benign change to our DNS configuration, where we wanted to remove the trust of some of our certificates. So there were a couple of entries which we didn't no longer need, and we just wanted to get rid of them. So this change was applied, and about 10 minutes later, the whole Zalando went down, and we had like 404 on the sharp front end. And then immediate scramble. I also got involved here a little bit with the coordination of the incident. And we were starting to look what's going on. And actually at that point in time, a good part of our whole DNS configuration was deleted. So all kinds of domains started failing. So what happened was that we actually back in the day had some super tools which were configuring several AWS clusters. And the configuration change that was rolled out had actually a small typo in it. So instead of metadata, there was metadata in the text. So the whole YAML file was invalid, and the super tool interpreted this in a way that it said, well, apparently there is no DNS configuration anymore at all. So instead of just removing this one certificate, it went ahead and kind of removed all the certificates from all the different AWS clusters. The tool got in a kind of stuck state where it couldn't go back and forth. It also got stuck deleting part of it because of AWS deletion protection. We were basically sitting in that call, and as we understood the situation, we came up with a plan to manually restore all the DNS entries. So we scrambled to find and reconstruct the DNS entries from several sources, share them in Excel sheets. Some developers pasted them into their etc hosts, like back in the early internet days. In the end, we got out of this within about 3.5 hours, which is, I think, a very good timeline to get through an incident of that magnitude. But needless to say, this triggered about like 9 months of follow-ups, improving our posture around this kind of super tools, which are kind of super delicate in a larger like distributed architecture.
Let's talk a little bit about Zalando and the size of the engineering team, because I think in Europe, Zalando is very well known, but you're not that known in, for example, the US, I think. You recently became a Zero customer. We can talk about that, but I now know your numbers, and it's in some cases even mind-blowing how much load and complexity you have in your system. So talk a little bit about Zalando, the architecture, the size of the engineering team, and the challenges you're facing in the reliability SRE team.
Okay, it's about 2,000 engineers, 250 teams. The whole infrastructure is deployed on AWS, and all applications run on Kubernetes. So it's a very homogeneous fleet. We are relatively distributed or highly distributed with our architecture. We have around 3,500 microservices that we operate across 250 Kubernetes clusters. So it's quite sizable architecture that also underwent several revisions. So back in the day, it was kind of a small PHP app. Then it evolves into a larger Java monolith, and then eventually it was broken out into microservices, which allowed us to move a lot faster. Right now, there are like a big variety of different business functions that are supported by this platform. It's not just a web shop that we take 2,000 engineers to operate. There's a whole like logistics operation that is part of Zalando. There's a bank that is part of Zalando. There are multiple different shop front ends. For example, About You was also recently acquired. So it's a pretty diverse portfolio of applications that we support on top of a kind of homogeneous application platform that we centrally provide. Along with the Kubernetes offering, there's also managed Postgres, managed Kafka, where we also are active in the open source communities. For example, the Postgres operator Spilo from Zalando is quite used around the industry, and also we have our in-house open source Kubernetes ingress proxy called Skipper, which has also seen some uptake in the community.
And on the platform, or overall, when we talk about observability, you decided very early on open standards, right?
Yeah.
I remember you were an early adopter of OpenTelemetry, but even before that, you were an adopter of OpenTracing.
Yes.
And one of the largest and earliest Lightstep customers, Ben Siegelman, who was also on this podcast, right? The founder and also the founder of OpenTracing and the founding member of OpenTelemetry. So tell me why you have done that move and why you selected OpenTracing, OpenTelemetry for your standard across, I think, all Zalando.
Yeah, I mean, this predates my time at the company a little bit, but I know the basic rationale behind it. I think here it is a special situation since Zalando back then was really fast growing, really tech oriented, and there were a couple of really strong engineers that shaped those decisions, which also got a lot of agency. So there's kind of a lot of like situations and mix that play a role here. Overwhelmingly, it was engineers which were at the most business critical applications around the checkout, so where the transactions and the money is most relevant, so reliability is most financially relevant. Let's kind of phrase it like this. And the problems of cross-team incident mitigation were really prominent. So it was quite usual that you had like 5 teams being in an incident, staring at their dashboard, and everything in their domain was fine. Like my dashboard is green, my dashboard is green. So you start kind of passing around user IDs and kind of grabbing the logs to kind of see where a certain customer journey failed. And it was in this situation that we understood that there needs to be, or how good of an answer distributed tracing actually is. And then Lightstep was kind of the first company who really had a convincing tracing product that was like able to really solve the problems and not just like more of a prototypical implementation like I would look at Jaeger. It's I think quite limited. So we ended up with embracing open tracing as the primary instrumentation method at Zalando. So the guidelines, and this was a long journey from this realization to this being conclusively rolled out. But the principles that we are teaching today and that we largely implement are everything that happens in a transaction context, like an HTTP request, should be primarily monitored as a trace or inside of a trace. So for example, if an error is occurring, put that as an error event into the trace, don't put it to the log. And similarly, if you are counting things like requests and so on, why are you kind of incrementing extra metrics? Well, just count the events, the spans that you produced. So it's extremely capable as a kind of default substrate for all kinds of observability. A lot of this kind of event-based observability that other vendors are also preaching is actually possible on top of traces and has been used in that way. But it requires a strong platform that is able to do all the aggregation post hoc, right? So we didn't want to do the math in our infrastructure. We just wanted to collect the events, send it out, and then have the vendor kind of take care of it. And that was quite a journey. Also, the pricing model played a role in the beginning. Lightstep was seat-based priced and service-based priced. And it was really encouraging to just spam spans wherever you want. It doesn't cost anything. Just record it. We will store it. We will make it available for analysis. And so in this way, we got a lot of adoption. We got a lot of good use. But it's also became like a very high volume, very business critical application, and a little bit of a like special situation. I don't think there are too many large companies which are all in on tracing for their observability in Europe or in the US for that matter. And a lot of the time, this kind of adoption from, okay, I'm pretty happy with my logs and metrics to, okay, we now fully embraced tracing and we do it the other way. I think that is often like the like a gap that is significant friction to come over.
You also need a certain maturity in engineering culture, right? Because I mean, I think you do a lot of the instrumentation yourself, right? So you add the traces and the data and the context you want in the trace inside of your application code, and then you have to transfer the context, etc. So it's, I mean, there are APIs, SDKs from OpenTelemetry that you use, but you still need to know how to use it, how to apply the semantic convention, but also what data to put in, etc. So I could see that this takes a while to get to a good practice there, right?
Yeah, absolutely. So one thing that we implemented was library wrappers around OpenTelemetry. I think also if you look at the specs, it's fairly complex in ways which I don't really understand why it's all needed. Like the way metrics are submitted, where you can have individual attributes along with a metric. For me, it's like if you create a metric, it kind of has its identity as a time series on the back end. It should have its identity as an object in the application. So, and then you can submit data points like float values into that stream that you created. But I think personally, it's completely sufficient to have kind of only attributes which you create at metric at the initial time when the application is spawned. So you kind of have objects for all the different time series that you want to track. And the current like OpenTelemetry model is much more dynamic. When you have an observation, you can submit in a value to a metric and it has certain kind of attributes along with it, which makes it a lot more complicated. Not, I mean, for the backend, for retrieval, it's surely convenient and all has its place, but I think this is additional complexity that needs to have a similar kind of payoff on the other side. What do we really gain? And a lot of libraries kind of in the past did it differently. And I thought like good enough. We packaged this kind of simpler primitives. Like here you have a metric, here's some span annotators. Here's just like auto config, the Zalando way to instrument a Python application with the auto instrumentation that we think are fine, that security has kind of vetted. And you can just include that very easily into your Python app without kind of being exposed to the full complexity and without worrying so much about where to send telemetry and so on.
No, that makes sense. That makes sense. But you mentioned the size and the number of traces you're creating, right? We are talking in trillions.
Yeah, I think we pushed 60 million a second at Cyber Week. So it's insane.
It's insane. Yeah, 60 million a second. Let's think about it, right? Well, spans, right? So that's a lot of data, and that also creates issues, right? I mean, we are now working together, and we are processing that amount of data, but there are multiple dimensions which we could talk about, which I think are interesting. One is that you have to send that data to the vendor, right? I mean, you are creating the spans inside of your application, then you have to send that data to the vendor, which creates so-called egress cost, even if you have private link, etc., which if you are at the size of Zalando, we are talking millions of dollars a year, right? Just for sending the data, so that smart sampling strategies inside of your data center makes a ton of sense, because you don't want to send the data over to the vendor and then remove it there, because then you have already paid for it, right? So I think that at that size, you have to have a lot of strategies in place to deal with that amount of data, right? Without losing the core context that you want to have. And I know also Lightstep had these satellites and local caches and mechanisms there. And we implemented something similar at Zero. We call it Intelligent Edge, where you essentially cache data so that you can decide when the trace is ready, if you want to keep it and send it, or if you want to not or remove it, right? Basically. So tell me a little bit about your experience with sampling and sampling strategies and how to deal with that large amount of data.
Yeah, I mean, a lot of this, like a big drawback of Lightstep is what did never allow any kind of things in this regard, right? We had one global sampling knob that was given to us, which was kind of saying, this is the global sampling rate we're going to apply. And then there was the cost, the pricing model change, where eventually we kind of had to pay for our volume. So for a long time, we could just completely ignore all of this. A, we didn't have any knobs, and B, we weren't priced by it. So it was, yes, egress cost was something, but it was not like completely insane. Not during off Cyber Week, it was not kind of that heavy. So there was a lot about cost transparency, about making sure the developers eventually understood which things are like most expensive. For example, some kind of rule logic inside of our proxies was kind of triggered for every single HTTP request with like 2-3 spans inside of our proxy. And then if you have like 20, 30, maybe sometimes deeper call chains, and for every call you have that 3 spans in, that's per interaction, it's a couple dozen of spans that you just add to every transaction. So that kind of became clear that it's not a good idea. And in the end, I think we just removed it. But I think the not actually sure what the team implemented, but we were discussed, and what I found quite sensible was kind of a feature flagging approach here. That you say, well, actually, sometimes I'm interested in this, and we do have feature flagging rolled out and available, so why not just make the telemetry toggleable with a feature flag, so you get it if there is an incident and you want to know about it. So I would say for a long time, this was kind of relatively naive, very focused on transparency. I actually wrote some, like one of my more popular open source project is a sampling calculator, which we actually use to manage this better, because we had this kind of fixed sampling rate. So if we are at like 30% sampling, for my aggregates, like the counts and the error rates I derive from that, how much accuracy do I still have? And the developers always feared that once we kind of do more and more sampling, all their telemetry, the metrics that are derived from it, are going to be rubbish. And that is the case if there's extremely low volumes. But you have to be quite low volume to actually for this to become a problem. And then this kind of little app, it's just like, it's a nice reactive JavaScript app where you can just dial in all the percentiles and the sampling rates, and it gives you just an information about like what does the sampling look like. Now, for -0, we are entering a new age, and I think the ability around shaping that traffic, the improvements in sampling have definitely been on our list and a selection criteria that was important to us. I think here just getting the ingestion architecture right was for us a big topic, where we didn't want to introduce central data plane components that are kind of centralized into our architecture. We have this decentralized Kubernetes clusters, and we wanted to keep the traffic local to there and then directly send it out. And then basically once you get the rough architecture right, you have a whole funnel of kind of sampling decisions you can make along the journey. You can sample inside of the application. You can sample in the hotel collectors. You can maybe sample at a like vendor provided broker component, another hotel collector inside the architecture. And then you can sample at the back end. This is a good amount of knobs to have. I think it's architecturally a good approach. And this is basically the level of understanding I currently have. So I think it will be around tuning these knobs correctly. And the specific thing that we want to have is that for the very high volume requests that come to the front page, we have a very different sampling rate than for something like reset password. And I think this is where like 95% of the spending or the cost savings come from, just isolating this extremely high volume endpoints and selectively dialing out the sampling frequency. And I don't know, I mean, my bet is we probably have to kind of do that close to the root span. So selecting the endpoints that when we are creating the spans and making the sampling decisions there. I think this is something kind of to do within the next phase once we are really 100% live with the system, which it's actually currently kind of a hot phase still, where we are kind of switching out the old vendor. So I will be sleeping better in a few weeks when we are over that hump. Yeah.
What you're describing is really a lot of customers who are way smaller, right? They don't have to deal with that problem, right? You can basically just send everything. And then there are multiple steps until to get, I would say, the Zalando scale, where you have to do that very diligently, as you explained, right? On multiple levels, right? Inside the application, on the collector level, in the backend. And I was actually, you just mentioned it between the lines, that I was talking about this with Ben Sigelman recently. We had a call, and he told me that he wanted to get this in the standard, that you have different levels of instrumentation. So essentially similar to what you have as log levels, right? Where you say, I have a debug level. And that would be actually pretty cool, right? If you would have that in the OpenTelemetry standard, that you can say, hey, I have multiple levels of instrumentation. And also in combination with the AI today, you could say, and if I reach an incident, I can get a higher detail level of tracing, as you described with your proxy, right? Which you turned off because you maybe don't want to have that for every trace because it's just too expensive, right? It's too much data at that scale. But in certain situations, you want to turn that on, like give me debug, and then you want to get all the insights, which is currently not a standard. There's no standard way of doing that, right? I mean, you can implement that on your own, but that would be actually a pretty cool feature, I think, for the standard to have that different types of investigations levels for instrumentation.
Yeah, 100%. And I think this is really a good tangent here to talk about the end game of observability, right? Because I think we are like always navigating trade-offs. And I think OpenTelemetry was not so great because it was innovative and did a lot of new things, but it just like provided this kind of bottleneck, like this, I don't know, this hourglass architecture, right? It's this integration point at the middle, which kind of allows the complexity reduction. Everybody kind of agrees to send in this way, so the data integration problem is basically solved. So, and it's not the most performant, it's not the most pretty, but it's just, it gets the job done, and it just, having the standard is so nice, especially for large enterprise, right? Our switching costs for like sending data was approximately zero. I could just send this to a new vendor, can just dial the knobs and deploy a couple of config lines. So that was kind of a major undertaking in the past. So huge benefits from there, but it was not an innovation where we have a new way to monitor things. So the basic problem you always have is how much of your events that are happening in the machine are you actually serializing and sending over a wire. And the cost differential actually matters here. The reality that we thought like 10 years ago, networking is going to be so cheap, disks are going to be so cheap, we can just send more and more and more and more, and we will figure it out. That didn't really happen. And probably it's not even a great strategy. But I mean, I think selective, adaptive telemetry is something that would be, for me, like a future step where we could evolve to. I don't know if this will be economical, but I still have some experience on this old Solaris systems where we had dtrace or sophisticated debuggers. So we could take a production system, we could just ask, how often was this function called? Or I could ask, well, if disk latency was larger than 10 milliseconds, give me a whole stack trace of what the application and the kernel actually saw. That was a capability that that platform had. And I could just do that. I didn't have to write any instrumentation. I could write instrumentation to make this easier, but it was completely dynamic. I had some production and I could understand production behavior. And for me, the best definition of observability is, am I able to understand the behavior of my production system at the time that I need it, kind of well enough to do my job? That would be kind of a good definition of observability. And for me, this, for example, definitely contains, well, am I able to inspect payloads, right? Of a Python app that sends something, well, show me what you sent. Like, do I want instrumentation for this that I'm kind of filtering out in the future, in the pipeline somewhere? No. Do I want to have even the code on every HTTP call or on every kind of stringer allocator or whatever, right? This can be fine-grained. Do I want to decorate this with thing? Probably no. Do I want in an incident the ability to see this? Probably yes. So I think this backchannel semantics or this like log levels are also a little bit of a sad situation if you have to kind of log everything and then kind of filter it out. But okay, you can set the log levels in that way, but very globally. But basically, give me an instrumentation config that I deploy at runtime to kind of make the application tell me the relevant things. I think that would be, for me, really cool to have. Like, I don't know, I think a couple of people are going this way. Also, the continuous profiling products, some of this are getting close to this. So I think there's a like more and more kind of mind share of this being a future goal. But yeah, anything that can get us closer, I think it's always valuable, and it solves the cost problem as well, right? Because then you would kind of by default send actually very little. You only need business and product information, from my experience, most of the time.
Absolutely. Absolutely. When I was in Berlin this week, I met Frederick, the founder of Polar Signals. continuous profiling tool, and I think they released it yesterday, right? A kind of an AI-based continuous profiling optimization tool, which what I've understood, I need to get him on this podcast to talk about it, but I think it's turning on more profiling or heavier profiling for a while to look at the specific services that and then use AI to suggest optimizations, right? Which I like because I think as a developer, you normally just don't have the time, right, to do that in production. Right? You probably would, but as many things, you are working on new features, so you don't have the time to every week look at your profiles or do a proper profiling and then do some optimizations. Maybe you are missing some very low-hanging fruits to optimize CPU memory usage heavily. I think that's a smart idea, and the AI actually is an enabler to do those tasks automatically for you and turn these things on off dynamically for these situations. I think that will be a big use case in the near future.
Yeah, 100%. There is this big risk or fear that code quality is going to be so much worse because AI is just vibe coding everything. And it's certainly true. But this is a counterexample, right? Where we do have actually the capacity now to do a lot more maintenance. We are not kind of usually profiling all our code for like the worst bottlenecks. We only do that once we have a clear signal that we are really, really too slow. And just you can put that probably in the CI pipeline soon. You just run that and then detect performance bottlenecks. And that will certainly help if we can catch kind of a number of like performance pitfalls in this way. Let's see.
And yesterday posted a small video from Silicon Valley. I don't know if you remember it, but it's 6 years old now. It was funny then, but now it's really hilarious from my point of view. It's when he said to AI to remove all the bugs and deleted all the code, right? And so they
Oh
were like,
yeah.
well, why did the AI do that, right? Made a
Yeah.
mistake. And he said, no, actually, if you think about it, it just found the optimal way of removing all the bugs. And
Yeah.
that's probably, it was pretty much seeing the future, right? 6 years ago when that episode came out, but now it's pretty hilarious in my point of view. I loved it. Let's talk about a different topic. I mean, you are a frequent speaker at conferences, and I don't know when it was, but I think we were sitting in Berlin and you talked about that idea of building kind of a Monitorama-like conference where, I mean, everyone in this industry remembers Monitorama. It was a very specialized, cool conference in the US. By the way, I just read that maybe it comes back. Somewhere I saw a news that they were thinking, but it's actually not there anymore. And you said you wanted to build something similar because it's actually something that I think the whole community will enjoy. So tell me a little bit about this idea. I think you were in a sabbatical during that time, right? And you had time to think about different things. So tell me a little bit, how did you come up with the idea, and it's actually happening, right? So tell us a little bit about that.
Yeah, SignalsConf Berlin, September 10th and 11th. What's the history behind it? I was the program chair for SRECon last year in EMEA. And when I was asked to do this, I was excited to have the honor to do it. But I also said, well, I don't just want to run another SRECon. I think we have kind of a little bit plateaued as reliability engineering as an industry with regards to innovation for a relatively long time. We had Kubernetes come out, Docker come out, distributed tracing come out, but those are all technologies which are kind of almost 10 years old. And I think there's kind of, it's also a good sign. You kind of not having one revolution after another in a sense. You're kind of figuring out how to do production at scale. I think there's a fair bit that was done in terms of innovation. But by that time, like the big elephant in the room is kind of AI and how AI is changing reliability. And I see like at least 2-3 different angles on how this is going to bring kind of big changes. So what we did at SRECon EMEA last year was really focus this around data and AI, and also bridge the communities, really bring people in that are working on AI from the other side. Like we had Anthropic there, we had people from the data space there, we had NVIDIA there, also like GPU monitoring was a big topic. So, and I thought that was a really successful event and a really nice kind of way to connect communities that don't usually talk to each other. And there was kind of a secret panel with charity mayors on it, and like Todd Underwood from Anthropic and Niall Murphy, but also Maria Fechtomova from like MLOps course at Databricks that she does, and Sylvain from Rootly, who's heading the AI labs. And that was like fantastic, such great conversations. And so for this year, we were really thinking, how can we take this to the next level? How can we shape the conversation? How we can platform the conversation that is really helping us all to understand what will happen? There are like thousands of ideas that are kind of in the air, like we just talked about, this AI-enabled continuous profiling. And like Agent Zero came out, like this is a crack pipe idea for like 10 years. Everybody was like, yeah, we are going to have automated root cause analysis and automated incident mitigation. I was like, guys, we tried. You will be in false positive hell for the next weeks until you figure out to switch it off and go somewhere else. And now, like since half a year or a year, it's like, this is actually possible. It's actually not longer completely a dream. And this will bring a lot of change in a lot of ways. Like people are going to vibe code a ton. People are going to build more and more rich interactive applications where you don't have like catalog browsing, you have conversations that need to be monitored in a whole different way. And all this is going to come to you once the incidents start rolling in, right? Like how if your chatbot is misbehaving, the diagnosis of this is just like stupendously difficult. Also, as witnessed lately by Anthropic Claude Code postmortem, where there were kind of very subtle, I forgot the woodcast this time, but you had this kind of very like long reports of Claude misbehaving. So I thought we need to do something, and you happen to be nearby. Hannes from Checkly, Hannes Lenke, is also like an early supporter here. And we right now have a really strong team, a program committee of like 20 people that are kind of aligned in the vision to bring this kind of small, focused event, really narrow on that topic, AI and reliability, in a way together that kind of bridges communities and makes the discussion happen. And we modeled it after Monitorama because it's just our favorite conference. I think it's really outstanding in its kind of way. It's enabling conversation, and it's the whole way which is kind of really, really excellent. It's the way you as a participant have such a shared like understanding of the conversation because it's a single track and it's small, so you can kind of communicate with people which are innovating, either speaking, having a booth, exhibiting, or just attending and also thinking about the problem space. Yeah, but the traction is very positive, a lot of energy, and I'm already very much looking forward to being in the room in September and just being part of that conversation.
Yeah, great. So, as you said, it's in September in Berlin. What are you looking for at the moment?
It's a good question. I think like we are always looking for supporters and people that want to be kind of involved in some form. So I definitely encourage you to sign up to our newsletter, to be in touch. If you have interest in sponsoring, definitely reach out and attend if you like. We're also doing something with lightning talks a little bit different. So we realized, right, this is so fast paced. So the talks that we are getting now, like September, it's like a couple of months. Like things happen so fast. So we thought like, let's have lightning talks, but the CFP for the lightning talks actually way closer to the event. So we will open that in August. So if you buy a ticket, you are able to submit to the lightning talks. So in this way, we are kind of encouraging the participants to come on stage. And if you have a message you want to share, that is a way to kind of get in very late with stuff that is top of mind that you want to bring to the community. So that's one thing you can definitely do for this event. And then, yeah, I mean, too much to kind of already announce, but I'm pretty confident we will have this being a regular thing.
Good. I mean, we are a big supporter, also a sponsor with Dash Zero. I like the idea. I think it's great for the community, especially this high focus on AI and reliability. I think, as you mentioned, right, I think there was not too much innovation, but now it's pretty disruptive, the way AI is entering. And I totally agree with you, like as many, not only in coding, when the models came out in December, things changed. You actually saw that root cause analysis is there, at least in a lot of cases. So it's getting better and better. And so things will change, right? And then at one point, when you rely on those, you can automate things. You can close the loop to the developers. I think there will be a lot of change. So I'm really looking forward to the conference, being there and supporting this. Thanks for, I mean, I know that you do a lot of work for this, also in your basically free time. That's amazing, right? It's really a big thing for the community. And I know that the committee and speakers that are lining up are world-class, right, from everywhere. So it's a great opportunity to meet the community in Berlin.
Yeah, 100%. And this was just too tempting because we had all the right people in the room. And again, thank you for your also early support in this. And that I think it was really in the cards to do something special here. And gaining that momentum and capturing that momentum was like just very, very interesting and exciting ride. Conference organizing is, of course, like it's a death by 1,000 paper cuts, right? You have so many things to do. And I also want to give a shout out to my producer, Rob Como, who is really teaming up with me and doing a fantastic kind of job of helping me with the day-to-day on this. And so shout out to all the sponsors, all the program committees. So I don't feel like I'm doing this alone. I really feel like I am just the crystallization point of kind of a large group who is kind of looking at this and saying, yes, we want a Monitorama in Europe. Yes, we want to discuss reliability and AI. And yes, we want to do it in Berlin. And so we're providing that space for everybody who wanted to be a part of this.
This was really fun talking to you. I think we could talk way longer, but I think I'm really looking forward to meet you in person again soon. And thanks for being on this show.
Thank you, Mirko. Greatly enjoyed the conversation.
Thanks for listening. I'm always sharing new insights and insider knowledge about observability on LinkedIn. You can follow me there for more. The podcast is produced by Zero. We make observability easy for every developer.